Okay, so everybody's going to get in this situation at some point in chemistry where you ask the question, what do I do now? This could happen in a variety of ways and a variety of reasons. For example, you might forget the density formula. Density equals mass over volume, but what if you forget? We want to know what the mass of something is. Well, if I know the density of lead is 11.4 grams per cubic centimeter, I want to get rid of the label cubic centimeter and I want to get just grams. So if I plug in what I know, cubic centimeters, I have 19.84 cubic centimeters. The cubic centimeters left are canceling out and you're left with just grams. So you can use this technique, this method to do just anything really. As long as it has a label, we can do it. We can figure out the volume. Again, that's one thing that in the density problem, manipulating that volume can be sometimes tricky. But if we have a mass of 50.0 grams, and I want to get rid of the label grams, and I want to get it into cubic centimeters. The problem is asking for cubic centimeters. I just plug in my numbers. The density, they say, is 0.950 grams per cubic centimeter. Now notice this, and I talk about this all the time in class, notice that I'm plugging in my numbers at the end. Otherwise, you're going to worry about what goes on top and everything else that's getting you sidetracked from the type of thinking you need to do. Now, if we do some other common examples, say we're going to be cooking. We have a crowd of 600. We are given a certain amount. Okay, this right here is a conversion factor. You can start with that. Just pay attention to where your label ends up. If I have 600 people, I need to know essentially how many teaspoons will we need to end up with. So if I get rid of my label of people and get it into teaspoons, my problem is done. The labels cancel out. I take a look. I have 2 teaspoons for every 10 servings, okay, or every 10 people. So the problem is actually quite simple. It's just knowing how to set it up and get started. Sometimes you just have to get started. Okay. We take a look at how many cups are in this number of teaspoons. However many teaspoons you get. I'm just going through the problems real fast. I'm not worrying about punching in my calculator quite yet. Let's say we had, for example, 30 teaspoons. It ended up being 200 or something like that, but it doesn't matter at this point. I want to know how many cups are in that many teaspoons. Well, I need to get rid of the label teaspoon. I need to get it into tablespoons. And then I can go from tablespoons into cups. Okay? No, you're not going to need to know all these conversions. This is just an example. This is all English system, so we really don't care about that stuff. It's all foolishness anyway. So just stick to the labels here, and basically you just plug in your numbers as you go. Okay, now getting into a little bit closer to true chemistry applications. We're going to take a look and we want to know how many students, how many lab stations can I get if I have just a 50-gram spool of wire left? Hey, my budget is really tight. I try to save money. I try to, not order too much stuff. This is all the copper I could find. So I take my 50-gram sample of wire. I want to know how many students I can get out of that. So grams to students. So to take a look, I have 1.84 grams per student. Okay, so it's just a simple conversion there. I'm going to get a weird decimal. That just means that I have enough for a certain number of students plus just a little bit more, which you gerbils usually mess up something, so I got to make sure I have a little bit to spare, right? Now, we're past the point in chapter 3 we talked about the metric system, and I taught you how to swing the decimals and so on. We're past that point now. We have 750 decigrams. And I need to know how many grams that is. Yes, I want you to use a factor label technique for it. 1 gram is 10 decigrams. In the last chapter, I said, well, your decigrams is here, swing it over 1. That's to introduce the concept and how to figure out your conversion factors. But we use that swinging of the decimal to figure out or determine what that is, what that conversion factor is. Now we get to volume problems. Okay, I showed you some of those. Again, you have 14 grams. Get rid of grams, get it into cubic centimeters. Okay, micrometers we can do. We have 0.073 centimeters. If you swing the decimal and leave an answer, it's going to be wrong. All you have to do is get rid of centimeters and get it into micrometers. But you might not know that conversion. So what you do is you go What might be more familiar for you is going centimeters to meters, and then you can go meters. Remember micrometers, that's that weird U thing. We have 1 meter is 100 centimeters, and then 1 meter has 1 times 10 to the 6th micrometers in there. Okay, so you can do it that way. You could figure out how many micrometers are in a centimeter. You could do that, but you can also go up to the meter and then back down. We can do multiple dimension or multiple steps in the dimensional analysis. We have 1 day. Okay, that's a label. Then we can go from days to hours, and then we can go hours to minutes, and then minutes to seconds. Most of you will probably do that, but you can shortcut this a little bit. 1 day, yeah, well, we know days to hours. And if you know how many hours there are in, or how many seconds there are in an hour, that's fine. There's 3,600 seconds to the hour, and 1 day is 24 hours. You can shortcut it. They all end up being the same thing anyway. Okay? So if you know some shortcuts, this is all about dimensional analysis, using uh, conversion units, dimensions, to arrive at an answer. I showed you that problem with the Firkins worksheet. A bunch of weird, they're all English system labels, but we use that because you're not supposed to know those. It's all focusing you on getting rid of labels. So let's take a look at some more complex problems and we'll be done here. The reason these are more complex is because we have rates. We have 2 labels we need to change. I have a rate of 40 kilometers per hour. Now notice that I put the hour in the denominator. Unfortunately, we don't have the technology to write it this way, but you'll always see it written in the problem like that. But you want to make sure you get that hours in the denominator. As soon as you do that, you can just focus on labels. I want to know meters and seconds. Okay, now notice that I didn't start with 30 seconds here. I want to show you what it looks like in case you start with your conversion rate. I want to know meters in 30 seconds. So I'm going to get rid of my label kilometers and get it to meters. Done. Okay, that is my label here. I want to now know how far have I gone in meters if I've gone 30 seconds. Well, I'm going to get rid of the label hours and I'm going to get it into minutes. You could go directly to seconds if you want, and then minutes to seconds. And now I have to factor in the fact that we had 30 seconds. See, it doesn't matter what you start with. Many people would start with 30 seconds. And we convert from seconds to hours. Okay, you can go that one step, 1 hour is 3,600 seconds. And then we can go get rid of the label hours and to get it to kilometers, and then kilometers to meters using the conversions that were given. 1 kilometer is 1,000 meters, not the other way around. 1 hour is 60 minutes, 1 minute is 60 seconds, and then we had 30 seconds. Same numbers kind of fit in. Everything cancels, and we're left with meters in both cases. Okay, now one last set of problem. If we take a look at this one, this is an important one. A lot of people miss this one. 7.21 grams per cubic centimeter. Okay, I want to know what its density is in kilograms per cubic meter. All right, so grams to kilograms, that's easy. Okay, 1 kilogram is 1,000 grams. All right, but the problem is this cubic centimeter thing. Cubic centimeters into cubic meters. All right, 1 meter is 100 centimeters, easy. But I have cubed, so I'm going to have to cube these numbers. Okay, now your labels will cancel out and they fit in just fine. Okay, we take a look at the speed of light. Okay, I want to know how many hours it takes. We have 150 million kilometers. Okay, I want to know how many hours it takes. Well, kilometers to meters. Okay, now I can go meters to seconds. Okay, that's my 3 right here. Then I can go from seconds to minutes, and then minutes to hours. Problem is done. Just plug in your numbers and you're good to go. Okay, here's another one of those cubic problems. We take a look at 2.5 grams per cubic centimeter. Then you can go grams to kilograms. That's done. Notice in each of these, I just solve one label all the way to what I need, and then I leave it. Okay, now I need to get rid of cubic centimeters, and I need to get it into cubic decimeters. Be careful on these. 1 decimeter is 10 centimeters, but it's cubed. So I've got to cube this as well. Okay, 1 kilogram is 1,000. Okay, 10 cubed is 1,000, so the thousands end up canceling out. I end up with 2.5 kilograms per cubic decimeter. Okay, now that should be enough to get you through. And remember what you're walking in with, what you have in your hand, and you should be good to go with those problems. Good luck.